Hit record. You might want to show your grandma how to look at that link that I sent, which is a recording of that session.
Yeah.
Just look at that email and click on that link and then find your file and click on it. And then everybody can watch that recording of how it went. I know she's pretty suspicious of internet or online stuff, so might be worth having her watch that. All right. You mentioned last time long division of polynomials, right?
Yes.
Okay. Let's do that for starters. There's all kinds of stuff we need to cover, but I would rather you tell me what to cover based on your memory of what was on that exam than anything else.
Yeah, I'm just trying to find it in my notes right now.
Well, rather than finding it in your notes, I'd rather you try to memorize this stuff.
All right.
In other words, forget your notes. Seriously. Pay attention to what we're doing here and try to memorize the method.
All right.
That's what's important. If you're doing along a polynomial into a polynomial, that's what we're doing here is dividing. Very first step is to divide that into that. What do you get?
X plus 5.
No, just divide x into x squared.
X.
Yeah, in other words, I know what you're doing. You're figuring out the answer, but I'm trying to teach you the method. You're not going to learn the method by giving me the answer all at once. In other words, you're smart enough to know that x plus 2 times x plus 5 is equal to this quadratic. But I'm trying to teach you the method, and it's going to get harder very next problem. But the first thing you do is divide x into x squared, you get x. Then you multiply that by both terms to get x squared plus 2x. Then you subtract. X squareds cancel. In other words, long division is always subtraction. And now you repeat. In other words, now you divide that into that. And you get plus 5. And now you multiply that times both terms. You get 5x plus 10. Subtract, you get a 0 remainder. That means that x plus 2 times x plus 5 is equal to that quadratic.
Right.
All right.
So you don't, when you go back and you multiply the x times x plus 2? And
yes.
So you
in other words,
whatever.
The first step is only divide the x into the first x term.
Okay.
That's the first step, which produces that x. And then you multiply that x by both terms each time. Here, I'm going to give you another one. This one will be a little bit harder. Pulling it out of my book. Hold on a second. Yes. Good one. Here our divisor is a little more complicated. And our dividend is a little more complicated. Now, this pattern that I just showed you is all there is to long division, except for one other thing. Okay?
Yeah.
The other thing is that both your divisor and your dividend have to have all powers of x represented.
Right.
Okay,
Right.
so I'm missing an x squared in the dividend. So I have to add a 0x squared.
Okay.
Now I have an x to the fourth, an x cubed, an x squared, and an x. Same thing in the divisor. Now, from here, it's exactly the same as what we just did. Just do it step by step. What's the first step?
We divide 2x to the fourth by x squared.
You get what?
2x squared.
And now what?
Then multiply that back by the divisor.
Okay, so that gives you 2x to the fourth. These will always be the same. And then what else?
Minus 4x to the third plus 4x squared.
Yeah, the only point in putting that 0x squared there is as a marker. In other words, you want to make sure your columns line up. Now, what's below that line I just drew?
The difference.
Okay, so I'm subtracting as always.
So negative x cubed.
No. What you have is a positive 3 minus a negative 4.
Plus 7x cubed.
Plus 1.
But, really?
Yeah, this right here is plus 1. Everybody has troubles with subtracting negative numbers. You just got to get used to it. You're pretty good with your arithmetic, but this maybe is a chink in the armor here. We'll have to maybe go over that. Okay, and then what else?
So we have negative x cubed plus x.
Hold on, it's not negative x cubed. What is 3 minus a minus 4? Remember, we're subtracting every term in row 2 from row 1.
So x cubed.
Positive, okay.
Plus.
We're subtracting. We got 0 minus 4.
Minus 4x squared.
Okay. Now you always just bring down the next term.
All right.
So that's bringing down 5x. Another reason why you stick these 0 markers in there. Because we have to have everything line up. In other words, you don't want to be subtracting an x squared from an x cubed. You want to be subtracting an x squared from an x squared. Okay? Now, it doesn't matter how big the divisor or how big the dividend, everything is repeat and stir. In other words, the next step is to do exactly the same process as you did on the last step.
So 3x cubed divided by negative.
It's just x cubed, okay?
Oh, so now we divide.
You're dividing this into that.
Okay.
You're always dividing this first term in the polynomial into the first term of the dividend. First term in the divisor into the first term in the dividend. What is that?
Just x.
Okay, plus x. I need the plus sign because this is part of a polynomial. And it's the second term. If I leave that plus sign out of there, then it makes no sense whatsoever. It says 2x squared x. So you got to put the plus sign. Now what?
And then multiply it back.
Okay,
so
tell me what to write.
X cubed minus 2x squared plus 2x plus 0.
Not yet. No, the last step was multiplying the x times the 2, which we did. Now subtract.
But you don't need a plus. Okay.
Not yet. After we subtract, we bring down the next term, which is a minus 1. First, we subtract. In other words, we're always subtracting the top polynomial minus the bottom polynomial.
So 6x cubed or squared.
Hold on. We got x cubed minus x cubed. That always results in 0. That first term is always going to be 0. 100% of the time. If you've done your division correctly, it's always going to be 0. Now what is this? Remember, we're subtracting. We have a negative 4 minus a negative 2.
Negative 2.
Okay. X squared. Keep going.
Plus 3x.
Now bring down the next term.
Minus 1.
Okay, now repeat.
Negative 2 or minus 2.
Going.
And then multiply back. So then minus 2x squared.
Oh, okay. Keep going. Got to multiply minus 2 times minus 2x.
Just 4x.
Correct. Plus 4x. Keep going.
Minus 4.
Okay, and then subtract. That's going to be our remainder. What is that remainder?
Negative x plus 3.
Okay. And the remainder is always divided by your divisor, which is x squared minus 2x plus 2. And so you could just put a negative sign in front of that, and that would be your remainder. And that's how you do long division. And that pretty much covers as difficult of a problem as you'll ever have. In other words, this covers where you have to put in the dummy variable. It covers 3 repetitions, but notice every repetition is the same. The difficulty is the fact that you're always subtracting. And a lot of times you're subtracting negative numbers. Like this right here, half my students would miss that. Because you got a negative number minus another negative number. That just confuses everybody. I don't believe you need it, but I'm going to test you anyway.
All right. Yeah, that's pretty simple. I remembered it being simple.
By testing you, I mean I'm going to run you through 5 minutes of this. What I want you to do is give me the verbal answers. I'll type them in as quickly as possible.
9. 0. 132. Or negative 132.
This is subtraction. This is not multiplication. In other words, what these flashcards are going to do is they're going to throw addition, subtraction, multiplication, and division of both positive and negative numbers at you randomly.
Negative 1. 0. 7. Negative 77. 7. Negative 3. 5.
Okay. You're near perfect on everything except where there's lots of negative numbers, and then you take about twice as long. which is fine. I don't need to have you spend time on this site. But you need to be perfect on this. If you're not, you need to be. Because when you take tests, if you don't know you're perfect, you're always going to use a calculator. You don't want to have to use a calculator on this stuff.
Right.
And your skills in this area are pretty good, although I noticed a couple of instances where they weren't so good when we were doing some of those problems. But algebra is all about just doing that multiple times on every problem. It really is. All right, let me give you some practice problems at the end of the chapter on long division. You get a couple of them in a row, and I will assume you know how to do it.
All right.
We can go on. I'll start you out with easy. Just tell me everything to write. You don't need to tell me your steps. Just tell me what to write. And you can't even see where I'm pointing, but you know where I need to write it. So
yeah, x above the x squared minus underneath the dividend.
Yeah, you don't need to put that minus sign there. Just always know that long division is subtraction.
All right. And then x squared minus 2x. And then plus 9x minus 5.
Repeat.
And plus 9 on the top. Then minus 9x.
Actually, just 9x.
Just 9x.
I'm not going to write the negative sign, and we're just going to assume long division is always subtraction.
And minus 18. And plus 13 underneath that is our remainder.
Okay, so that's the remainder, and if I wanted to write it as a quotient, how would I write it?
Over x minus 2.
Yeah, I would write it as, first of all, plus 13 over x minus 2. And that's your answer. If you were to multiply that times that, you would get the quadratic in the middle.
All right.
And that's an important concept to know. Because one thing it tells you is that unless this remainder is 0, these two are not factors. The only time these two right here are factors of that quadratic is if that remainder is 0.
Right.
As a demonstration.
I think they would also have problems like that weren't quadratic. They were just like two-term. What do you call that?
You're talking about something like this.
Mm-hmm. Mm-hmm.
Okay, that's called a rational quotient, where division isn't called for here. Even though there's the division line, this is just a rational quotient. I don't advance by trying to do that division.
What if they had like 3x plus 7 on the top or something like that?
Same thing. I cannot advance that.
So
that is hyperbolic in nature. By hyperbolic in nature, I mean it's going to look something like that. Always. Now, if it was 3x plus 12 up there and x plus 4 down there, well, now I can factor the top, and so I've got 3 times x plus 4 over x plus 4 Now I can cancel the x plus 4s, and that thing's equal to 3.
Right.
So these are either rational quotients, and that's as far as you can simplify it, or they can be simplified by factoring. But factoring is that important. Factoring applies to lots of problems.
But I wouldn't have to do the quadratic formula or anything like that.
No.
Okay.
First of all, a quadratic formula is only needed if you're dealing with something like this. That's the only time. And it always works if you have something like this. And what might be that? How about something like this? Okay? Now, I don't know if that's factorable or not. I just invented it in my head. So I don't know how much time I would spend trying to factor that even. But what I know for sure is if that's all equal to 0 and I want the solution to that equation, then x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So if I don't even want to fool with factoring ever, I can always go that way. Always. Even when they give you well, I shouldn't really say that, because sometimes they're going to give you a problem. They're going to say, just factor it. In other words, they may tell you this. They're not going to give you an equation. Oh, excuse me. They're just going to give you this. And they're going to say, don't solve it. It's not an equation. Factor it. So now you can't really use the quadratic formula. You have to do as they advise. And how does that factor?
X minus 2, x minus 5.
All right. Let's talk about something else. I want to make sure we cover.
All right.
I believe you've got the hang of the polynomial long division, right?
Yeah, I won't forget that.
Okay. Let's talk about the laws of exponents. This is extremely important.
All right.
What's that equal to?
X to the 5th.
What's that equal to?
X to the 5th.
What's that equal to?
X to the 6th.
Excellent. Those are the only 3 things you need to memorize for your rules for exponents.
All right.
Now, next question. Did you have logs on this test?
No, I didn't.
Okay, good.
It was just the rudimentary stuff.
Okay, let's go over solving some equations. Unless you, go ahead. No, if you want to suggest something that you remember that was on the test that we haven't talked about, by all means.
I'm just kind of looking at my textbook and seeing what chapters it looks like.
That's fine also. It's still always better if you direct rather than me. But there are certain things that I know for sure you're going to have to know. And, yeah. You got something, or you want me to give you something?
I see properties of integer exponents, and also
that's what we just did. The 5 minutes we just did was just that.
All right.
Those were integer exponents. Okay. Let's go further. What's this? These are not integer exponents. These are fractional exponents.
I know I can change x and 1/3 to root 3x.
Better. No, hold on. It's not 3x. It's the cube root of x.
Yeah, cube root of x.
But it's easier if you leave it in exponential format.
All right.
The reason is that when you have radical signs, you can't really apply your rules of exponents. But your rules of exponents work whether they're integers or not. In other words, if the base is the same, x and x, and I am multiplying, what am I doing to the exponents?
Adding x to the first
So it
power.
does not matter whether they are integers or fractions. You still add the exponents. The rule is you add the exponents, or if you got division going on, you divide the exponents. One other thing that I didn't cover, let's talk about that. What if you have this? In other words, here I got different bases, but the same exponent.
Right. Don't you kind of put them together like x to the third, y to the third, or
and you can go either way. What usually happens is you get started with that and you split it into these two. Okay, how about this? You have simplifying radicals?
yeah.
That's on your test?
Yes.
Perfect. Hold on. Let me erase the page. Let's go there. Because this utilizes this principle that we just talked about. I can split that up into the square root of 25 times the square root of 2. In other words, what I had was the square root of AB, which is the square root of 25 times 2, equals the square root of 25 times the square root of 2. And that simplifies to 5 square root of 2. So you never want to give an answer that can be simplified.
Okay.
Now,
So
there are some exceptions to that. Notice, how about this? Can I simplify that?
square root of 2, square root of 5.
It's a good answer, but it's not a simplification. What is called a simplification is only if you can pull a whole number out of it. So when you're trying to figure out how to factor 50, you don't want to factor it into root 5 times root 10. Neither one of those is a perfect square number. You want to factor it into two numbers, one of which is a perfect square, always. That's the rule you use to simplify these radicals.
All right.
Okay? And so I would never do that. In other words, square root of 10 is the most simple. Why separate it into two terms instead of one? It's one thing if you can pull a whole number out like I did on the top, but if you cannot, do not simplify. So I would never do that. Okay, here, let me just give you a bunch. And what you're going to find out here is that it's very helpful if you know your perfect square numbers. So over here on the right, I'm going to write the perfect square numbers. I suspect you probably are pretty good with those. Nonetheless, I'm going to put them over there because this is what you're looking for in terms of factors. And the last one is 100.
Square root of 100, root 2.
Yeah, square root of 100, root 2. What's the final answer?
Like 10 something.
Not a decimal. The final answer is this.
Oh.
They do not want a decimal answer.
Okay.
Ever. Not at this level. Once you get to algebra, you're done with decimal answers. Everything needs to be in radical notation. And that's why you need to be able to simplify these radicals. You can't put that in your calculator. It's not going to give you anywhere close to the right answer. It's not going to give you that, which is the right answer.
All right.
It is going to give you a decimal. It's going to give you 14 point and change. Okay? But the key when doing these is when you're looking for factors of the number that's in the radical, try to find the biggest factor possible. Let's do this in 2 steps. I want you to give me, in other words, this is the square root of some a times some b. Tell me what the square root of a is and the square root of b is going to be. In other words, I'm going to break this into 2 square roots. What are they going to be?
Square root 16 and 5.
Good. And you put the perfect square first, because you know that's going to turn into a number.
Right. So then it just becomes 4 root 5, doesn't it?
Yeah. However, let's go back a step. I want to demonstrate something here. My goal really is to factor that 80 into 2 numbers, one of which is a perfect square root, okay? So in my head, I see 4 times 20, right?
Okay.
4 is a perfect square number. That should work. That gives me 2 root 20. The problem is that that is not simplified. In other words, that root 20 is root 4 times root 5. And now I've got 2 times root 5. So I get to my same answer. It just took 2 extra steps, right?
Right.
Because I didn't find the biggest perfect square factor. You did. When you did it, you came up with 16 times 5. A lot of people wouldn't realize 16 was a factor of 80, first of all. Good for you to know that. That shows me your math skills really are good. Most people really don't see that. This is most people's first step. And it's okay. You don't have to find the largest perfect square. Even if you find a smaller perfect square, you still get to the right answer. It just takes a couple extra steps.
Okay.
So it's useful to know these numbers and to try to find a factor of whatever that number is that is one of those numbers. And before we leave this subject, I feel like you're going to be pretty good on that subject.
Do you think there would be stuff with like
What's that?
Do you think there would be questions on the Algebra 1 test with multiplying rational exponents or dividing rational exponents?
You mean like that?
Yes.
Okay. How do you do that?
Do you have to put them with the common denominator first?
First of all, it's 3 to the what?
To the 1/3.
Minus 1/4. In other words, the principle is, if I am dividing same base, different exponents, then I am subtracting the exponents.
Okay.
That's the exponent rule that you have to memorize. If I'm multiplying, if I'm doing 3 to the 1/3 times 3 to the 1/4, then I'm adding those exponents. Now, to either add or subtract those exponents, you're correct. I've got to find a common denominator, the least common denominator. So let's deal with the top one. What's 1/3 minus 1/4?
1/12.
There's your answer.
All right.
1/12. Now, I can leave that in exponents if I want, like that, or you can write it this way. I personally, I mean, that means the same thing. That is the 12th root of 3, which is also what that is. If I said square root of 3, I could write that as 3 to the 1/2.
Yeah.
Okay. Now, just a second. I had a real thought there that I lost. There was another subject that I wanted to cover immediately.
where you bring numbers and variables with exponents from like one from the top of the fraction to the bottom of the fraction to.
Yes, thank you. I don't know how you knew that.
Yeah.
That's exactly what I wanted to cover, because this gives people a lot of problems. Negative exponents.
Yes.
What's that equal to?
So I think I remember anything to the -1 power is 0, right?
No, it's 1 over that base to the +1 power.
Okay.
So it's 1/2. So as all negative exponents mean is you move it to the other side of the fraction bar and you change the exponent. So if I gave you this problem, what's that equal to? Move it to the other side of the fraction bar, change the exponent to a positive number.
It's 3 to the first power over 1.
Exactly. Negative exponents are that easy.
Okay.
Okay. Now, you're going to get problems like this. Yes? No?
I had a lot of problems like that on my test.
Okay. Here, let's make it a little harder. Okay?
Okay.
It doesn't matter how many variables I add. I could add a z, an a, a b, a c, a d. It doesn't matter. Your process is you take one thing at a time. First of all, let's deal with that. What's that equal to?
4x squared.
Oh, deal one thing at a time.
4.
Okay, so go in the numerator or the denominator?
Numerator.
Now we deal with the x's.
X squared.
In the numerator. Now deal with the y's.
At the same time?
Nope, next. We're all done with the numbers, we're all done with the x's. The only last thing we have to deal with are these y's.
You flip them?
No, you don't flip them, you subtract the exponents.
Y. Just y?
What's 2 minus a minus 2?
Y to the 4th.
You have a habit of dropping negative signs. Not just you, everybody. Okay? People want to drop negative signs. When there's subtraction and you're subtracting a negative, they want to just drop one of them because they hate negative signs. Everybody hates negative signs, so there's a real tendency to drop them. Do not drop them. You will miss the problem. They're as important as positive signs or multiplication signs or division signs.
I was just trying to...
All right, now let me change this problem just slightly. Make that a -2 and make that a +2. Now what happens to the third term?
It goes on the denominator side.
Well, if I want to do it straight away, I can write y to the -4th. But almost every math teacher I've ever heard of wants all your answers with positive exponents. So this is not a satisfactory answer because it's got a negative exponent. So you're right. You got to move that y to the other side of the fraction bar. So you end up with 4x squared over y to the +4. And this is the proper answer. However, you don't have to think about that when you're doing that first step. Just subtract. In other words, start with -2 and subtract a 2. You get -4. In other words, don't worry about any of those other rules until you've simplified it to step 2. Now see that you have a negative exponent. I got to move that y variable to the other side to get this. Now, the first time I did this with you, we didn't have any negative exponents, so I didn't have to worry about that. All right. I certainly can find other things to do unless you have some suggestions.
I really don't.
Okay,
That seems to be the bulk of
go
it.
back and solve some equations. That's the one other thing I'm absolutely certain you're going to have to do. I'm just going to start with easy ones and we'll go from there. Just what I'd like you to do, Nathan, is just read the next line to me. You don't need to tell me what you're doing. You don't need to tell me you're going to subtract 9 from both sides. Just read the next line.
All right.
And if you want to use a pencil and paper on these, that's fine. If it helps you, go ahead. That's something you would be allowed to do on a test, correct?
Yes.
They let you have a pencil and scratch paper?
Yeah, they don't let you have a calculator, though.
Good. Good for them.
Yes.
That's really good for you, actually, because you're good. Most people aren't as good as you at those calculations. They aren't. So the fact that they don't let you use one is your advantage to you.
My next line is 3/7 x minus 6.
Equals, don't forget the equal sign.
Equals 0.
Okay, when I subtract 9 from both sides, here's what I'm doing. Minus 9 there, minus 9 there. Those two 9s become 0. That's why I subtracted 9.
Okay.
Right side becomes 6.
Oh. I thought, so sometimes aren't you supposed to get 0 on one side?
That's if you're dealing with a quadratic. I'm starting with the most basic of equations here. I'm starting with linear equations. Linear being the power of x is 1. It's not 2. It's not 1/2. It's not 3. It's always 1.
Okay.
Those are linear equations. Very simple to solve. Once you get into quadratics, then you get 0 on one side, everything else on the other. But like I said, I don't know what to do next for you. I can only guess, but I want to get you good at solving simple equations.
All right.
What's the next step? You can do it in 2 steps or 1 step.
Yeah. I wrote x equals 6 times 7/3, and my next line just says x equals 14.
Good. That's exactly perfect the way you should do it. In other words, I could have multiplied both sides by 7 and then divided both sides by 3, but you did it all in one step by multiplying both sides by the reciprocal of whatever that is.
Okay.
And that gets rid of that coefficient. And now, to solve the other, what do you do without a calculator here? Step by step.
Invert and multiply. Or no, you already.
This is a simple division problem. But you have 2 choices. You can do 6 times 7, 42 over 3.
Yeah, that's what I did.
That's not what you should do. What you should do is divide top and bottom by 3, turning that into a 2, this into a 1, and now it's 2 times 14. Notice the way I did it, I never dealt with a number greater than 14. The way you did it, you dealt with a number 42, which you then had to divide by 3, and that's not trivial, especially without a calculator.
You want the simplifying first?
Absolutely, always. Always look to simplify. Always. You will find it makes math so much easier. It makes your arithmetic so much easier because it keeps all your numbers small. That's the thing. You always want to deal with the smallest numbers you can possibly deal with.
I agree.
It just eliminates potential mistakes. All right, let me look in my book here, and we'll go up a notch.
Here, I just found a little bit.
Tell you what, let's do this problem first. and then we'll go to yours.
All right.
I want to make sure you know how to do problems like this. So this time, I want you to tell me what you're going to do each step.
Oh, geez. Factor out from the left side first.
Before you think factoring, notice that nothing can be factored. It's already factored. This 4 was already pulled out. So you need to go the other direction.
Multiply out.
You need to distribute.
Distribute.
So distribute the left side, you get 12x minus 20. Distribute the right side, what do you get?
Negative 2x.
Negative 2x. 2 times negative x is 2x.
Minus 16.
Don't forget the negative 6x.
Minus 6x.
Now what?
I would just re-simplify on the right side.
Okay, so the right side becomes what?
Negative 4x minus 16.
And the left side stays. And now what am I going to do?
Sorry, it's on my end. Add 4x to the left side.
Good. Conceptually, what you're going to do here is you're going to gather like terms. That's what they call it. In other words, every place where I have an x, I'm going to put that on the same side. And every place where I just have numbers, I'm going to put that on the other side. And I can do it in any direction I want, but I would prefer for the coefficient of the x term to be positive. So I'm going to move this minus 4x to the left, giving me, and I'm going to move the minus 20 to the right, giving me what?
Negative 4.
Nope. Here's the way, yeah, let me just go over this, because I'm sure you were taught this in school. You're going to add 20, right? And this is the way you do it?
Yeah.
Okay. I don't do it that way. To me, it seems like a waste of time to write that. Whoops, excuse me. And the reason being is the only reason I'm writing this is because it's going to make all of that disappear, right?
Right.
So why write it? Let's just not write it. What I'm going to do is I'm going to take that minus 20, I'm going to move it to the other side and change its sign. So I'm going to make it a plus 20. Now simplify. Saves you a step every time, no matter what you're doing.
All right.
So now I get minus 4x plus 4.
All right.
Now, what?
Divide 16.
Hold on, I got an x on the left side and I got an x on the right side. You've got to finish gathering your like terms.
So subtract negative 4x.
Well, let's add 4x instead of subtracting a negative 4x.
Right.
In other words, I'm just going to move that 4x to the left side and change its sign. So it's going to become plus 4x. You get whatever over there. So now I got 20x equals 4. What's x equal?
1/5.
That's how you do it.
All right.
Okay. We've got a few minutes. Let's just do some more simple linear equations, which may seem backwards because we started out on quadratics. That's okay. They're kind of two different principles.
Yes.
We'll get to quadratics again, progressing through. But here's a linear equation. Again, it's x to the 1, it's numbers, and it's another x to the 1.
All right, let me write this down.
Okay. The first step here is kind of critical. There's a great first step to do. to turn this difficult problem into an easy problem?
Common denominator.
Kinda. Yeah. What's the least common denominator between the three denominators that you see?
12.
Okay, so I'm going to multiply both sides of this equation by 12. What's the left side become?
Oh, I didn't think you were going to do it like that.
Well, I'll show you why I did it in one step. It's because we're going to turn a really hard problem into a super easy problem in one step.
Got it.
So the left side becomes?
The left side becomes 4x plus 3.
Right side?
The right side becomes 12x minus 2.
See why we did it?
Yes, yes, I did.
Eliminate all fractions in one step. If you can do that, it's usually a good idea to do that, other than the other way, which would have been to start there and simplify that using a common denominator of 12. We could have done it that way, but whenever you notice that there is a common denominator that applies to all denominators in your equation, think that as a first step. Now,
Okay.
let's continue. Which side are you going to put the x's on? Which side are you going to put the numbers on?
X's are going to go on the right side.
Okay, what's the x's going to be?
8x.
And the numbers on the left?
1.
You're going to take that negative 2, you're going to move it to the right, and you're going to change its sign.
5. 5
Now, if
equals.
I've screwed you up teaching you that new method, go back to whatever method you used to use.
No, you didn't.
Okay, because here's what you used to do. I'm going to add 2, and I'm going to add 2. All I'm doing is not writing that step. That's the only thing I'm doing. Similarly, when we get 5 equals 8x, I'm not going to write divided by 8. I can see that 8 is a multiplier, so to get rid of it, I got to divide by 8. And that's all I'm going to do. Here's your answer.
X
As opposed to writing it like that. That's unnecessary waste of writing.
Got it.
Okay. Got time for one more, I think. Let's see if I can find just something a little harder.
Let me, I just found this
Oh yeah,
page.
if you found something, give it to me.
Alright, it's basically kind of just a list of the main things in what it says, chapter 5, which is the exponents and radicals.
Okay.
It says product of powers, power of a power, power of a product, negative exponent, zero exponent, quotient of powers, power of a quotient. We kind of did all that, didn't we?
We did every single thing except the zero exponent. Let's talk about that. What is this?
0.
No.
Or 1. 1.
Big difference. Those two numbers are not the same.
Yes. It's 1.
What is this?
1.
What is this?
1.
What is this?
1.
We've just covered the zero exponent.
Awesome.
We covered the quotient, we covered the product, we did everything else.
Okay.
Okay. Let's call it a day for that.
Yeah.
Day. Now, do you, or not a day? Are you interested in another session tonight?
Yeah, I will call and let you know because I'm gonna look through the notes that I took for the test when I went down to New Mexico.
Yeah.
And if there's like nothing else on there, I might just say we're good.
It's your call. Whatever.
Yeah,
I'll be around. I'll be around. If you need a session tonight, let me know.
okay. Thank you.
Good luck on your test.
Thank you. Have a nice day.
Bye bye.